What is this? What are the allotropes of the sulfur? Isn't it? And right. First of all, tell me beta, what is the meaning of allotrope? What is the meaning of allotrope beta? Yes?
We have same chemical.
What is the meaning?
Same chemical formula, sir.
मेरे को सुनाई नहीं दे रहा वो उनको पूरा बंद करने के लिए देखो बेटा allotrope means what is the definition beta? What is the definition beta?
The same chemical properties but different physical properties.
That means an element, any element if you observe, an element, isn't it, which can exist two different physical forms, many different physical forms, many different physical forms, that means their appearance is what? Different. Their appearance is what? Different. What is the common thing it is having? Chemical properties. Their chemical properties are what? Same. Isn't it? Because they are having what? Same number of electrons. What is the reason? Because remaining in this one? Very simple. Because it has same number of electrons. Same number of electrons. And why they are exhibiting different physical properties? Because they are having different in what? Mass number. Whenever if you observe mass number is different, then their physical properties will be different. Whenever they are having same number of electrons, their chemical properties are same. So what I mean to say in this one, allotropes are those in which they exhibit different physical properties and same chemical properties. Now, how many allotropes are there for sulfur? Let me check this one better. How many allotropes are there? Let me see this one now. Isn't it? First of all, if you observe here, alpha sulfur bolte beta. They're all non-metallic because already I told you sulfur is what type of element beta? Non-metal. Therefore, all allotropes are non-metallic in nature only, right? Next, they exist in alpha form. Alpha form is called what? Rhombic sulfur, we call this one better. Alpha form is called what? Rhombic sulfur, isn't it? And beta form is called what? Monoclinic sulfur. Monoclinic sulfur or prismatic sulfur also we can call, right? Generally we use the name called monoclinic sulfur. Next, if you observe, one more is called gamma monoclinic sulfur. Gamma monoclinic sulfur. Next one, isn't it? X sulfur or plastic sulfur also we can call this one. This is called plastic sulfur, isn't it? But in our class, in our textbook, according to our syllabus, and even if you consider the importance, if you observe, alpha and beta both are important one and stable, and remaining they're unstable. So generally we don't get in our textbook section, right? Next. Now, if you observe what alpha, beta, gamma forms of sulfur are crystalline in nature. आपको पता है ना what is the meaning of crystalline? How they look crystalline nature में कैसे दिखते थे बेटा? How do they appear in crystalline nature? Yes, beta. How do they appear in crystalline form? What is the main nature of crystalline beta? Samiksha, how it looks beta crystalline? What are two types beta? Crystalline, amorphous. किसी को पता नहीं difference between crystalline and amorphous?
So crystalline has a plane surface.
Crystalline will have this type of surface.
Plain surface.
Generally, crystalline compounds will produce sharp edges, isn't it? Example.
Crystalline has well-defined edges.
They are what type of things? They are ordered in a manner, isn't it? Whereas amorphous in terms of order type of nature, which are having what? Short range order. Crystalline is having what? Long range order. These we have discussed in the solid state, isn't it? And they're possessing what? A Foucault ring structure. I will show that one better. Foucault ring structure, how it looks. A crown ring structure better. How a crown looks, same thing they looks. And one form looks like a chair form better. How the chair looks, no? Like that also it will look. Chair form. That will be called X6 beta, isn't it? Hexaatomic, and this one is an octaatomic. Okay, let me see this one now here. Now, how many sulfurs are there beta?
6.
6. Now we have to call this one what? S6, and we can also call what? Chair form also beta. We can also call chair form. It looks like a chair, no? बूढ़े आदमी बैठते हैं ना, ऐसा दिख रहा है ना? Chair. This is our chair. Right? Now, in this case, if you observe the SS bond length, you are going to see 205 picometer, and the bond angle is 102. This data is no need to remember better. Just to explain, I have given this one. But S6, what type of structure it is having? Chair form. This you need to remember. Chair form will be present for S6. S side will have what type of structure? Crown ring structure, Foucault ring structure. We can call. These are the two things we have learned today better. First of all, that crystalline in nature. Second thing, S8 exists in the Foucault ring or crown ring, whereas S6 exists as a chair form. These are the three main points you have learned in this slide. Next, if you observe beta, this is the crown ring structure beta, isn't it? Crown ring. It looks like crown ring. Victoria, Queen Victoria, wear this type of ring, isn't it? So this is called what? Crown ring structure. See how many sulfur atoms you are having in this beta? 1, 2, 3, 4, 5, 6, 7, 8 sulfurs are there in this. 8 sulfurs are there. Now this is what? S8, isn't it? This is what? S8 beta. Right? Next, first we will discuss what? First type of allotrope, rhombic sulfur beta. We'll see what happened. Rhombic sulfur, right? So I will show how rhombic sulfur will looks. I will show that one first of all. Later we'll discuss everything. This is the rhombic sulfur beta. It looks like this. आपने कोई देखा ऐसा structure? Rhombic sulfur आपने देखा?
No, sir.
This is rhombic sulfur beta. S alpha we can call this one. S alpha. It looks like. इसमें crown ring आपको नहीं दिखा गया बेटा. मैंने बोला S alpha is octaatomic. Its structure is what? Crown ring. आप इसमें crown ring नहीं दिखेगा. Sir, where is the crown ring? ऐसा मत बोलना है आपको. इसे स्ट्रक्चर बेटा, स्ट्रक्चर आप नहीं, आपका वाटर का स्ट्रक्चर ऐसा रखता है, आप देख सकते हैं ऐसा स्ट्रक्चर आप? Do you find this structure in the water?
No,
Is it possible बेटा? और मीथेन का स्ट्रक्चर आप एक पॉसिबल है ऐसा आपका? आप देखते हैं? That is the structure, how the bonds are forming. How the bonds are forming, that is what chair form and the crown ring form. And don't say sir, इसमें chair कहाँ बेटा? देखो मेरे को दिखाओ chair, ring दिखाओ sir. ऐसा मत बोलो, क्योंकि this appearance I am saying. Isn't it? S alpha appearance. It looks like it's the rhombic sulfur beta. S alpha, isn't it? Next, you will see the properties of the rhombic sulfur, each and everything. Now, already I told you it is a crown ring structure, isn't it? First thing. Second, how to preparation? How do you prepare this rhombic sulfur? देखो बेटा, आपको 100% allotropes में अगर क्वेश्चन आए तो यहाँ पर आएगा बेटा. कोई भी टॉपिक पूछ सकते हैं इसमें. Which of the following is a true statement? ऐसा क्वेश्चन allotropes में आएगा बेटा. Mostly if you observe MCQs में allotropes में which of the following is correct statement? ऐसा क्वेश्चन आ रहा है बेटा. So, इसके वजह से statement आपको ध्यान देना है इसमें. You take a sulfur, roll sulfur and evaporate that one beta. Isn't it? In a solvent called what? CS2 solvent. And whatever you are going to get, that is called what? Rhombic sulfur. Okay, in this आपको एक important point है बेटा, this rhombic sulfur is a generally non-polar, does not soluble in the water, is insoluble in water, but readily soluble in CS2 because CS2 is what? Non-polar. So this is the case you can easily identify the rhombic sulfur because insoluble in water, soluble in CS2. Therefore, definitely you can easily identify by using this method. This is a method of identification of the rhombic sulfur. And certain amount of benzene also, because benzene also what happened? Non-polar. But generally we will take CS2 of lete beta. CS2. Completely soluble. But remaining it is a small amount. Small amount. And if they ask in examination which allotrope is the most stable of sulfur, क्या बोलते बेटा? Which sulfur is the most stable beta?
Rhombic sulfur.
Rhombic sulfur. Rhombic sulfur. S alpha is the most stable sulfur beta. It's the most stable sulfur. Next. And it is also called octahedral also because its structure also looks octahedral. So you can call octahedral. And it is having 8 sulfurs in the molecule. So it is shown as S8. Now this is the molecule of O2. आप कैसे लिखते बेटा? O2, N2. Similarly, sulfur आप कैसे लिखते? S8. We have to write it. The Fokker ring structure, मैंने already आपको बताया मैंने, which is having what? Crown shape actually, right? Next, if you observe beta, melting points. The melting point of rhombic sulfur is 385.8. Specific gravity 2.06. तो ये आपको थोड़ा ध्यान देना है बेटा, इसका तो आपको ध्यान देना है. Why I will explain later in the monoclinic sulfur. तो आपको 385 and 2 you have to compulsory remember, right? I will explain why you have to remember in the next slide beta. So melting point and density you have to remember compulsory, right? Now let me see next slide here. Already we have taken this. Next is what? Monoclinic sulfur beta. Next topic is what? Second allotrope is called monoclinic sulfur. This is called what? Beta. Okay, beta sulfur we can call this. Okay, it is called what? Beta sulfur or prismatic sulfur. Because of the structure they call like that, right? Now again, how to get the monoclinic sulfur beta? Isn't it? Rhombic sulfur, if you heat the rhombic sulfur, you are going to get the monoclinic sulfur, isn't it? If you cool the monoclinic sulfur, what you get beta? If you cool the monoclinic sulfur, what do you get?
Rhombic sulfur.
Rhombic we are going to get. That means both are interchangeable beta. Both are what? Interchangeable, right? So rhombic sulfur, monoclinic sulfur, both can be interchangeable by changing the temperature. You know what is the temperature? 369. Above this temperature, what will be exist? Monoclinic, gamma form. Less than 369 Kelvin temperature, what we get here? What we get here beta? Less than 369 temperature? Kelvin beta, this is Kelvin. This in terms of Kelvin. What we get here? Less than 369 Kelvin beta? Sonali?
Beta sulfur.
Alpha form. We are going to get what? Alpha form beta. So that is the reason alpha and sorry, यहाँ पर beta लिखना है ना, sorry, beta लिखना है. Beta form. Alpha and beta form both are interchangeable at what temperature? That interchangeable. That temperature is called transitional temperature. Now, what is the transitional temperature for this alpha and beta sulfur beta? What is the transitional temperature?
369 Kelvin.
369 Kelvin can be taken as a transitional temperature. At this temperature, both are existing. Above beta, below alpha. तो ये टेम्परेचर आपको कंपल्सरी याद रखना ही कंपल्सरी, राइट? नेक्स्ट, सो देखो, बिलो 369 केल्विन व्हाट इज एग्जिस्टिंग? अल्फा सल्फर. Above 316, what is getting here? Beta sulfur, isn't it? Beta. ये 2 पॉइंट आपको कंपल्सरी याद रखना है बेटा, isn't it? Next, we talk if we go to what happened at this temperature, this system both are existing better. So you just take this one beta, otherwise you can take the snapshot. After that you can make a notes also. Okay, it is there in the textbook beta. It is there in the textbook, right? Next, this is called what? Transition temperature. इसको एक स्क्रीनशॉट ले लो अभी मोबाइल पे, तभी आपको इजी हो जाएगा, right? Otherwise, I am recording the video. You can also take from the YouTube also, no problem. Next, we see what is the melting point of the gamma beta? 392. Now tell me what is the melting point of alpha? कितना है बेटा alpha के लिए? बोलो.
385.
हाँ, आप क्या बोलते हैं ना, melting point of alpha and beta increases or decreases? Order of the melting point क्या होता है बेटा? Less than देखना है, increase, greater than देखना है बेटा. What I have to keep here? Less than or greater than here? इसका कितना है? अल्फा का कितना है बेटा? 3
greater than
80. कितना आया अल्फा को?
385.8.
इसके लिए 392. तो लेस देन लिखना है ना, ग्रेटर देन बोल रहे हैं आप लोग. और स्पेसिफिक ग्रेविटी डेंसिटी कितना लिया आपने? इसके लिए 2.0 समथिंग आया. किसके लिए? अल्फा के लिए. और इसके लिए कितना आया? 1.98 आया. So it is greater. So what type of question you may expect here? What? The density of alpha sulfur is greater than the beta sulfur. Correct statement. The melting point of the alpha sulfur is what? Rhombic sulfur melting point is lesser than the monoclinic sulfur. These are the two statements we can get from this one. So that is the reason these two are important. It is there in the textbook. You have to note down this one. You can underline in the textbook this topic now. Next, one more thing. If you observe here, this is a very, very important statement in the, isn't it? Allotropes. Very important statement beta. What is that? If you observe, heating the alpha beta sulfur at 1000 Kelvin temperature. If you heat the alpha beta sulfur at 1000 Kelvin temperature, now the S8 will convert into S2. That means S8 is now converting into S2 at what temperature? 1000 Kelvin temperature. Isn't it? मैंने already आपको बताया S2 is a paramagnetic nature, just like what happened O2. क्योंकि O2 में अनपेड इलेक्ट्रॉन रहते हैं और H2 में भी but S8 is what? Diamagnetic beta. This is diamagnetic because when you observe the structure beta, everywhere you are going to get the bond pairs and lone pairs soon. Here we don't get any bit of unpaired electrons. No unpaired electrons here. Understood? No unpaired electrons here beta. So that is the reason आपको देखना है बेटा यहाँ पर. What you have to observe here? It is a diamagnetic. Which one? S8. That means what? Monoclinic, octahedral, or rhombic. Isn't it? They are what? Diamagnetic in nature. Whereas S2 and O2 both are what? Paramagnetic in nature. That paramagnetic in nature. Understood?
Yes, sir.
Next slide में देखेंगे अभी ये structure बेटा. It looks something what? Needle type of structure बेटा. When you observe the needle type of sharp structure, we are going to observe in this way. ये mixture नहीं है बेटा. आप जो खाते हैं ना, वो नहीं है ये. उनका फोटो नहीं, ये सल्फर का फोटो. कौन सा? मोनोक्लिनिक का है. मोनोक्लिनिक और what? गामा सल्फर का फोटो है ये. It looks was a needle type of structure देख रहे हैं ना. This is the structure of what? Monoclinic sulfur. Is it visible to you?
Yes, sir.
Yes.
Okay. Next, if you observe, third one, cyclic structure, S6 form, also called chair form also beta. Also in the chair form also. Isn't it? This is the structure of the chair. Generally old person बैठते हैं ना इस type of chair में. So this is called cyclic structure, chair form. It is having S6 as a molecular formula, and the bond length here we are going to see something like this. And sir, there are n number of subjects. That is, if you write what happened, n is equal to something other number, they are going to get one more allotropes also, but they are highly unstable. Okay, so they exist in the form of sulfur vapors S2 and S3 only. Mostly we get S2 and S3 that are existing, and remaining all are what? Highly unstable, so they are not present actually. So we can add S2, S3, which are little bit stable. Now if you observe S3 beta, it is having some cherry red color beta. Cherry आपको पता है ना, same color है सर. Where S2 exhibit violet color beta. They exhibiting what? Violet color actually. अब देखो क्वेश्चन आपको पूछता हूँ, आपको पता बोलना है बेटा. Which sulfur is the most stable sulfur? Rhombic sulfur is the most stable sulfur, right? And what is the transition temperature of monoclinic sulfur?
369 Kelvin.
369
Kelvin temperature. Very good. So with this what happened, we have completed the allotropes of the sulfur beta. Mainly आपको याद रखना है S alpha, S beta और S6 में तो chair form है, S2 तो paramagnetic. These are the main things you need to observe. You make the notes today, only complete the allotropes of the sulfur. Now let me see now preparation of sulfur dioxide SO2 को कैसे prepare करेंगे. Let me see this one. और इसका preparations क्या है, इसका properties क्या है, इसका structure कैसे होता है, everything will discuss now. First of all, we'll see the preparation of sulfur dioxide. These are also important one. There are three types beta. We'll discuss that three types actually. General method beta. This is general. We can write. Anyone can write here. Simple. Otherwise, I can also write like this also. S plus O2 gives rise to SO2. Simple thing. ऐसा भी आप लिख सकते हैं. अगर आप 8 लिए तो यहाँ पर भी 8 लेना है, यहाँ पर भी 8 ले. अगर यहाँ पर 8 लिए तो यहाँ पर भी 8 लेना है. So this is a simple preparation method for the sulfur dioxide. Just addition reaction beta. Only simple addition reaction. Now let me see the laboratory method. अगर आप लैब में प्रिपेयर करना है ना, अगर आप प्रैक्टिकल में आते हैं ना, लैब में प्रिपेयर करने के लिए आपको सल्फर डाइऑक्साइड कैसे प्रिपेयर करना है, इट्स अ वेरी सिंपल बेटा. आपको कॉपर लेना है, उस कॉपर को आपको सल्फ्यूरिक एसिड में डिसॉल्व करना है बेटा. ठीक है, लाइक दिस बेटा. यू टेक ए बीकर ऑफ वॉट, concentrated H2SO4, okay, and add some copper into this, copper pieces into this one. So when you add some copper pieces into this one, immediately what happens, sulfur dioxide will released. A gas of sulfur dioxide will be released and a byproduct of copper sulfate will be formed, isn't it? Let me see the reaction here. This is a sulfur dioxide gas will come from this container, isn't it? अब ले लेंगे और एक मेथड भी ले लेंगे, Na2SO3, सोडियम सल्फाइड बोलते हैं बेटा. दिस इज कॉल्ड सोडियम सल्फाइड बेटा, सोडियम सल्फाइड, सोडियम सल्फाइड. नाउ इफ यू डिसॉल्व, अगेन आप एक और एक बीकर ले लो बेटा, और इसमें HCl ले लो, HCl सॉल्यूशन ले लो, और इसमें आपको एक सोडियम सल्फेट Na2SO3 को ऐड करो बेटा. इमीडिएटली आपको कौन सा गैस आएगा, आपको SO2 गैस आएगा. इमीडिएटली आपको SO2 गैस आएगा. ये रिएक्शन सिंपल है बेटा, याद करने के लिए. हाउ, वेरी सिंपल. देखो सोडियम पॉजिटिव है ना बेटा, है ना बेटा, सोडियम इज पॉजिटिव, क्लोरीन इज व्हाट बेटा, यार नेगेटिव. तो पॉजिटिव को नेगेटिव को आपको जोड़ना है तो NaCl आएगा, और यहाँ से आपको हाइड्रोजन तो नहीं चाहिए ना SO2 प्रिपेयर करने के लिए. हाइड्रोजन ऑक्सीजन को वाटर से निकालो, और बाकी का क्या है बेटा, SO3 will now SO2 will give here. वेरी सिंपल है ना, इजी टू रिमेंबर ऑल्सो. ये रिएक्शन आपको प्रैक्टिस करो बेटा. सल्फाइड, when sulfide dissolve in HCl, what gas you are getting beta, tell me. When sulfide dissolving in HCl, what gas you are getting beta?
Sulfur dioxide.
Sulfur dioxide, SO2 you are getting here, right? Next we'll see what industrial method beta. दिस ऑल्सो इंपॉर्टेंट वन, इंडस्ट्रियल लार्ज स्केल में आपको क्या करना है इसमें। इसमें आपको ओर लेना है बेटा, आयरन पायरेट्स बोलते हैं इसको, FeS2 आयरन पायरेट्स, और इट इज अ ओर बेटा। ओके, नाउ दिस आप आयरन सल्फाइड को आपको बर्न करना है, ब्लास्ट फर्नेस में इसको बर्न करना है बेटा, इन द प्रेजेंस ऑफ isn't it? O2, in the presence of O2, burning is taking place at high temperature. This sulfides, iron sulfide will now convert into iron oxide to give the sulfur dioxide. तो आपको आएगा sulfur dioxide. Okay, you are getting what? Sulfur dioxide. How do you remember this reaction? Very simple. In industrial method, we are preparing sulfur dioxide by burning the iron pyrites of iron sulfide in the presence of oxygen, in which iron sulfide is converting into iron oxide. This is happening actually, right? This is happening actually. This you need to remember. Next, we'll see and how it is stored, because as a gas, no, gases cannot be stored normally in a container. So we need a cylinder at high pressure. So they store in a steel cylinder. Steel क्यों लेना है? क्योंकि वो reaction होता है iron से. तो steel आपको, which is unreacted with sulfur dioxide, that is nothing but steel. So we have to store in steel compartments only. Next, देखो बेटा, SO2 act as a reducing agent and oxidizing agent also. Why? Anybody tell me why SO2 can act as both oxidizing agent and also what? Reducing agent beta. It can act in both. What is the reason? Anybody? What is the reason beta? मैं कई बार आपको बताया बेटा, why this happens. Why this happens?
Because it can donate and also accept electron.
Very good. Because it is having intermediate oxidation, that is +4. +4, isn't it? Can convert into +6. Again, +4 may convert into +2 or 0 also. If it convert into +4 into +2, we are calling this one reduction. So called as oxidizing agent. If it convert into +6, we call this one oxidation reaction. We can call that one reducing agent. The substance which undergo reduction is called oxidizing agent. A substance which undergo oxidation is called reducing agent. Now sulfur dioxide can undergo oxidation and reduction because it is having intermediate oxidation state. Therefore, it can act as oxidizing and reducing agent. अगर कोई पूछे तो आपको ऐसा बोलना है बेटा, because sulfur dioxide is having intermediate oxidation state, can undergo oxidation reduction reaction. Therefore, it can act as what? Oxidizing and reducing agent beta, right? Next, we'll take some reaction beta, how it is acting as a reducing agent. Let me see this one. अब देखो बेटा, you know observe this reaction. तो आसान है बेटा, रिएक्शन याद रखना वेरी वेरी सिंपल है बेटा. देखो आयरन का ऑक्सीडेशन कितना है बेटा? यहाँ पर आयरन का ऑक्सीडेशन कितना है बेटा? +3 है ना, बिकॉज 3 क्लोरीन्स आर देयर, +3. यहाँ पर कितना है ऑक्सीडेशन?
+2.
+2. Iron undergone what type of reaction beta? Tell me.
Reduction.
Now, that is the reason this SO2 now is called what? Reducing agent. Now you are calling this one as a reducing agent. क्यों बोल रहे हैं आप reducing agent? It is reducing what? FeCl3. SO2 reducing FeCl3 from +3 to +2. But it will undergo what? Oxidation. देखो बेटा H2SO4 में सल्फर का ऑक्सीडेशन कितना है बेटा? H2SO4 में कितना ऑक्सीजन स्टेट है सल्फर का? What is the oxidation state of sulfur in H2SO4? What is the oxidation state of sulfur in H2SO4? किसी को पता नहीं?
Plus
Sir,
6.
plus 6.
+6, right? अब देखो सल्फर undergoing what reaction? Oxidation. The substance which act as a reducing agent undergo what type of reaction बेटा? Oxidation. देखो यहाँ पर प्रूफ है ना, देखो ये प्रूफ देखो, +6 +4 converting into +6, देखो यहाँ पर simple you can. That means SO2 will convert into H2SO4, FeCl3 will convert into FeCl2, and the byproduct you are going to get 2 moles. In this way you have to practice the reaction better. Okay, right. And one more reaction also we'll see better. KMnO4 is a very important reaction used in the volumetric analysis here. When SO2 reacts with KMnO4, यहाँ पर भी SO2 act as what? Reducing agent. Let me see is correct or not. See, KMnO4. Tell me better, what is the oxidation state of manganese?
+6.
Plus, जोर से बोलो बेटा.
+6 sir.
Plus, आप प्लस मेरे को आवाज आ रहे हैं, बाकी का नहीं आ रहा है बेटा.
+6 sir.
फिर से प्लस ही आ रहे हैं मेरे को, और कुछ नहीं आ रहे हैं. प्लस प्लस प्लस, कितना प्लस होता है? कौन बोल रहे हैं? समीक्षा.
यस सर, आप ऐसे ही कर रहे हो सर. +6 बोला मैंने.
+7 बेटा, +7 दिखा तो मैं, एक मिनट, ये देखो बेटा, KMnO4 है ना, आप देखो, यू आर कैलकुलेटिंग फॉर मैंगनीज है ना, राइट. पोटेशियम विच ग्रुप है बेटा? फर्स्ट बी ग्रुप है ना. पोटेशियम इज व्हाट? फर्स्ट बी ग्रुप. तो ऑक्सीजन कितना होता है? +1 हो जाएगा, है ना. 4 ऑक्सीजन है इधर, है ना. ऑक्सीजन का ऑक्साइड में कितना रहते हैं? -2 रहते, इज इक्वल टू 0. अब बताओ मैंगनीज का कितना हो जाएगा? +7 प्लस K2MnO4 में +6 हो जाएगा. K2MnO4 में आप कैलकुलेट करो बेटा, यू विल गेट द +6. यहाँ पर आपको +6 आएगा इधर कंपल्सरी, राइट. तो यहाँ पर कितना हो रहा है मैंगनीज का? यहाँ पर बताओ बेटा, समीक्षा इधर बताओ कितना हो जाएगा मैंगनीज का?
+2.
+2. समीक्षा सो रहे हैं शायद. हाँ, +2 बिकॉज SO4 कितना है बेटा? -2. तो मैंगनीज को कितना आएगा? +2. नाउ देखो, +7 कन्वर्टिंग इनटू +2, व्हिच रिएक्शन यू कैन कॉल दिस वन?
Reduction.
Reduction reaction. So now SO2 is reducing what? KMnO4 into what? Manganese sulfate. SO2 reducing the potassium permanganate into what? Manganese sulfate. But it will undergo again oxidation. देखो +4 यहाँ पर, सल्फर का यहाँ पर +. इसमें कंफ्यूज होने की चांस ही नहीं है आपको. आपको ये रिएक्शन ऐसा मत प्रैक्टिस करो बेटा. डोंट ट्राई दिस रिएक्शन मेनी नंबर ऑफ टाइम्स. अब इसको बैलेंस भी आपको आसान हो जाएगा बेटा. वेरी सिंपल टू बैलेंस. देखो बेटा यहाँ पर कितना इलेक्ट्रॉन्स एक्सचेंज हो गए बेटा? +7 से +2 कितना इलेक्ट्रॉन्स एक्सचेंज हो गए?
5.
+7 से +2, तो यहाँ पर 5 लिखो. और यहाँ पर कितने इलेक्ट्रॉन्स एक्सचेंज हो गए बेटा? यहाँ से +4 से +6,
2.
फिर यहाँ पर 2 लिखो. हो गया, बैलेंसिंग हो गया, है ना. आपको कैसे याद रखना है? सल्फर डाइऑक्साइड will reduce the potassium permanganate to give manganese sulfate. ये याद रखो. आपको रिएक्शन तो आएगा कंपल्सरी. Definitely will get the reaction now. Next we'll see the some more reactions, isn't it? Before seeing whatever, let me see the some physical properties better. Let me see the physical properties. After that we'll see the some more reaction. SO2 does not showing any color beta. It is a colorless gas, and definitely SO2 produce the pungent smell, highly soluble in water. क्यों बेटा? पता है आपको why it is soluble? SO2 when you dissolve in the water, immediately you are going, this acidic nature. Which oxide beta it is? SO2. Acidic oxide, isn't it? Having polarity, dissolve in the water because water also polar, will give what type of acid? H2SO3, sulfurous acid. ये आएगा आपको sulfurous acid. ना इसमें आप water निकाल दो बेटा, क्या आएगा इसमें water निकालने के बाद? If you remove water, what आएगा बेटा यहाँ पर?
Sulfur
What you are going
dioxide.
to get if you remove the water?
SO2.
SO2. That is the reason we can call H2SO3 is anhydride of SO2, isn't it? It is an anhydride of H. That means what? SO2 में water नहीं है ना, इसमें water नहीं. अगर water है तो क्या होता है ये? If SO2 contains water, क्या होता है बेटा ये? H2SO3 हो जाएगा. So what I am saying, anhydride of H2SO3 means which is not having water into this one. SO2 does not have water, therefore anhydride of H2SO3. No water it is having. अब देखो ये रिएक्शन ऑलरेडी मैंने अभी बताया इसको. देखो SO2 when react with water आपको आ रहा है एक एसिड आ रहा है H2SO4 H2SO3 and the oxide is called what? Sulfur dioxide, right? Next, if you see some more chemical properties. ये already मैंने आपको बताया बेटा. It is having intermediate oxidation state. That is the reason it can act as a reducing agent and it act as a oxidizing agent. मैं already आपको बताया. कुछ reactions भी हमने discuss भी किया. Next, if you take this reaction beta, it's an addition reaction. Completely both are adding here. NaOH, SO2, when they are added, what happened? You are going to get Na2SO3. But this reaction do not stop at here beta. It will take place continuously like this. Further amount of water will react here to give what happened? Sodium bisulfite. So, if we add NaOH in excess amount of sulfur dioxide in water, you are going to get sodium bisulfite or sodium hydrogen sulfide. Sodium bisulfite or sodium hydrogen sulfide, isn't it? So this reaction I can also write like this also. 2 moles of NaOH, okay, reacting with 2 moles of SO2 plus 1 mole of water, you are going to get 2 moles of sodium bisulfite, isn't it? This you are getting actually. This is the byproduct you are going to get here. Understood? So ये reaction भी थोड़ा important है बेटा, जरूर याद रखना है आपको, isn't it? NaOH when react with sulfur dioxide in presence of water, what is the final product you are getting? Sodium hydrogen sulfate. ये याद रखो आपको, sodium hydrogen sulfate आपको याद रखना है. Next, this is very, very important beta, very important. Action of chlorine on SO2. When you, isn't it, add chlorine gas and sulfur dioxide gas, both will be added to give sulfuryl chloride beta. You are going to get the sulfuryl chloride, isn't it? SO2Cl2 is called sulfuryl chloride. So generally, this is also called anti-chlor agent beta. What is anti-chlor agent? You know what is the meaning of anti-chlor agent? SO2 is called what? Anti-chlor agent beta. क्यों बोलते बेटा? Why you are calling SO2 is anti-chlor agent? Why you are calling like that? Do you know? Why SO2 is called what? Anti-chlor agent. Because it is removing the excess amount of chlorine. So for example beta, if you in the making of what clothes or paper, pulp industries, generally we use chlorine as a bleaching agent. कल ही आपको मैंने बताया chlorine is the best bleaching agent. अगर ज्यादा chlorine इस्तेमाल करें तो क्या होता है बेटा? Isn't it? जो ज्यादा chlorine रहते हैं ना उसको आप remove करना है. इसके लिए आप sulfur dioxide use करते हैं. Anti-chlorine agent means which removes the excess amount of the chlorine. Isn't it? So this is the reaction beta. So SO2 can act as an anti-chlorine agent. Next, action of O2, इसको तो addition reaction beta. Both will add to give SO3. ये तो simple reaction beta. SO2 plus oxygen will give SO3. These are simple reaction, addition reactions, right? What is the catalyst? Also आपको याद रखना है बेटा. Vanadium pentane. ये reaction में आपको contact process में आएगा बेटा. Contact process in the preparation of H2SO4 में आएगा बेटा. Right? Next, we'll see the structure of what SO2 molecule. What is the structure of what SO2 molecule? Let me see the structure of SO2 molecule here. When you observe the structure of SO2 molecule, it looks like this better. Bent structure it will produce. We'll have one lone pair like this. Because you see, 1, 2, 3, 4, 5, 6. Sulfur will contain how many electrons beta? 6 electrons. Generally, it will contain. The bond angle is 119 degrees. sp2. Why? Because one lone pair is there. And how many bond pairs are there? Total 2 bond pairs. Double bond also called one pair only beta. 2 bond pairs. टोटल कितना हो रहा है? 3 पेयर्स हो रहे हैं. 3 पेयर्स का मतलब क्या लेना है आपको? sp2 लेना है. तो sp2 हाइब्रिडाइजेशन. ओके. नाउ एक्चुअली sp2 का बॉन्ड एंगल कितना होना चाहिए? 120 डिग्रीज होना चाहिए. बट कितना आ रहा है आपको? 119. क्यों आ रहा है? बिकॉज ऑफ लोन पेयर का और बॉन्ड पेयर का रिपल्शंस रहते हैं ना बेटा. बिकॉज ऑफ लोन पेयर एंड व्हाट बॉन्ड पेयर रिपल्शंस, दिस बॉन्ड एंगल इज रिड्यूसिंग 120 to what? 119 degrees actually. Okay. Now in this structure, how many sigma bonds and how many pi bonds are having beta? How many sigma and how many pi bonds are having in this one?
2 pi bonds.
2 pi bonds, 1 sigma bond. Okay. So pi bond generally which type of overlapping present beta? Pi bond में p overlapping रहता है generally, है ना. एंड अगर आप स्ट्रक्चर देखो तो बेटा एस डबल बॉन्ड वो स्ट्रक्चर में देखो तो दोनों पे पाई बॉन्ड है, दोनों पे सिग्मा बॉन्ड है. बोथ आर आइडेंटिकल. दोनों का बॉन्ड लेंथ सेम रहेगा. isn't it? So इसमें कोई डिफरेंस नहीं रहेगा बिकॉज बोथ आर आइडेंटिकल है ना बेटा. ऐसे दिस इज द रीजन एक्चुअली. isn't it? ये स्ट्रक्चर है बेटा सल्फर डाइऑक्साइड. लास्ट फाइनली विल सी व्हाट एमसीक्यूज बेटा. कैन यू से व्हाट इज द प्रोडक्ट्स इन दिस केस? व्हाट आर द प्रोडक्ट्स you are getting? Which is the correct answer?
Option C.
Option C.
Fe2O3 and SO2, isn't it? ये बताओ बेटा, what is the product?
Option B.
Option B.
SO2 Cl2, right? अब बताओ ये इसका आंसर बताओ जल्दी.
Sir, both A.
Sir, option C.
Option C.
ऑक्सीडाइजिंग एंड रिड्यूसिंग एजेंट. ऑक्सीडेशन भी हो जाएगा और रिड्यूसिंग एजिंग भी हो जाएगा. नेक्स्ट हाइब्रिडेशन क्या है बेटा इसका?
sp2.
This is about today class beta. Okay, today I have completed the allotropes of the sulfur. उसका notes बनाओ और preparation of SO2, properties of the SO2 and chemical properties of the SO2. इसका notes बनाओ बेटा. टेक्स्ट बुक आप देखो, देखकर आपको notes बनाना है ना. ये टेक्स्ट बुक में आपको सारी ये मिलेगा बेटा. allotropes में आपको है ना इधर देखो. This is in the text book. Rhombic, monoclinic, isn't it? Everything is there. Sulfur dioxide preparations, chemical properties, isn't it? One question is also there here. ये question आपको try करो बेटा. Try to complete these things in your notebook. Right? Users कल discuss करेंगे एक बार. Already we have done whatever we have discussed. That is the users only. Okay, this comes under the users only, right? So this is only today beta. 1 minute of all of you. Already 11:45 हो गया. I'll take screenshot now. Later we can take the attendance. चलो मैंने screenshot लिया. If you have any doubts, you can speak better. Otherwise, you can log out.
Thank you, sir.